Cerebral palsy is a neurological disorder that affects motor skills and potentially cognitive abilities as a result of poor nerve stimulation of the muscles. The condition is as a result of numerous causes, not limited to restrictive oxygen during birth, brain infections, or infantile strokes. Because of the large range of causes and severity, affected individuals have a large variety of needs. Regardless, movement and coordination is critical during early development for children and is a primary area of worry for patients. Modern treatments usually utilize significant physical therapy in the form of play therapy. The primary goal of the design, then, was to marry those treatments with a cost-effective, compact toy that is both challenging and fun for use with toddlers and young children.
Okay.
When researching toys that already existed for patients of cerebral palsy, it was clear that most of them were created for worst-case situations. Often, they only had about 5 or 6 keys that were attached to musical notes made through a speaker. Our toy uses a variety of tactile and sensory elements to encourage controlled muscle usage while being simultaneously enjoyable for toddlers through young children.
So this is our CAD model. As you can see, there's all sorts of different buttons that can all be pressed in a variety of different manners, and they're large enough to allow for a kid with cerebral palsy to utilize them effectively. So this is the main rotating octopus head mechanism. As we can see, there's a track along the bottom that allows it to rotate along the base that has a stoppage feature on it. But as you see, this is a hollow shell, a hollow hole, which would be bad for manufacturing costs and time. So we have split it up into 2 different sections that will be easier on the print. An important consideration of any model is safety. And our prototype is very good for this because of its plastic material. It will be very light, and also because of rubber stoppers similar that you would see on a laptop make it really hard for it to be pushed by any outside force.
We chose a simple synthesizer for our octopus since we think the fidgety aspect of a synth in conjunction with its musical nature would effectively stimulate and invite a toddler with cerebral palsy to continue playing and switching it, fostering play therapy. In analog synthesizers, the voltage-controlled oscillator here generates a waveform like a square wave or triangle wave, just like any other sinusoidal wave, whose frequency or pitch is controlled by a voltage. However, since human ears work logarithmically and our 5 volts is linear, we use a current-to-voltage exponential converter to transpose our voltage into an output current that changes exponentially with respect to that voltage using a matched common collector BJT pair, which are these two. They have a very similar HFE. The VCO uses a current-dependent charging capacitor that charges or discharges to generate our waveforms. From there, the waveform is selectable by 2 momentary push buttons that direct its output through 2 P MOSFETs and an NMOS to the speaker. This fan is controlled by a single-pole dual-throw switch, and our voltage rails are generated by 2 series 9-volt batteries. That's it.
Good.
Our Octopus-themed toy is realistic in its bottom-heavy base and ABS textured plastic to ensure its durability and being handled by children with motor impairments. Its long-term viability is also supported by the fact that it grows in intentional complexity as the children matures and tunes their fine motor skills. The prototype must now undergo structured research and safety testing to validate its materials and therapeutic effectiveness in real-world settings.